This video we're going to go over the 3.1 notes and examples. So we're starting to think about parallel and perpendicular lines and a couple of the relationships formed by them. Starting with number one, two lines that do not intersect are either one of two things. They are either parallel or skew. And parallel is probably a term that you've heard before. We're going to probably dig into some new relationships within parallel lines. Skew may be a new term. So number two says two lines are parallel lines if they do not intersect, which is probably how you've thought of parallel lines in the past, and are coplanar. So in order to be considered parallel lines, they have to lie on the same plane, on the same surface, and never intersect. Number three, two lines are skew lines if they do not intersect and are not coplanar. So two lines that never intersect and are not completely on the same surface are considered skew lines. So we can use this diagram down below to kind of start thinking about pairs of lines that are parallel and pairs of lines that are skew. So in this diagram below, we assume that this is a perfect cube. All the angles are 90-degree angles. So we have kind of like the face here, and then we can see the different sides of the cube. These dotted lines are showing us like kind of the back corner that we can't see. So to be parallel, for example, we'd have like EH, and then we would have to have another line on that same surface. So that front side of the cube, both of these lines would be completely on that plane if it extended forever and ever. Now, if I look at this line EH, and then I'm thinking about a line that would be skew, an example that comes to mind right away here would be this line AG. So that's like the side of the cube. So those two lines would never intersect, and they are not on the same surface. So AG would actually end up coming through, a little hard to show here, but it would come through that front face of the cube. They do not lie completely on the same surface, therefore they are skew and not parallel. So I would go through, try 1 through 4, pause the video, and then come back and see how you did if this is your first time through this. So number one, lines parallel to CD and containing point A. So parallel to CD, and if it contains point A, we don't have a lot of choices here. It's got to be AB. This is the only one that contains A and would be on the same plane, so that plane would be the top portion of the cube. So this would be line AB. And number two, a line skew to CD containing point A. So this is never touching and not on the same plane. Looks like we have a couple here. We could use a H. Those are never going to touch, not completely on the same surface. And we could also use a G. I've seen some people thinking like AE. Yeah, that's true. If there were a line connecting them, we generally want to use existing lines on the cube. So EA would work if there were a line there, but we generally wouldn't use that. So good examples would be AH and AG. Number three, lines perpendicular to CD and containing point A. So perpendicular means they meet or cross at 90 degrees. So CD is here, and I've got my 90 degree there, so I know that this is perpendicular, and that line would be AD. That is the only line perpendicular that contains point A. And then number four, parallel to plane EFG and containing point A. So plane EFG is going to be the bottom. Not really a good way to show this. It's the bottom of this cube. So think about a cube or a dice or something, and it would be the very bottom edge. And so the only other plane on here that would not intersect the bottom would be the top. Right? Those are the only ones that wouldn't cross the bottom. And we name planes by any 3 points on the plane, not on the same line. So we could call this plane ABC. We could call it ADC, CBD, any combination of those 3, because they're not all on the same line, but they are all on the same plane. So I'm just going to say plane ABC. Moving on. Parallel postulate states that if there is a line and a point not on the line, then there is exactly one line through that point parallel to the given line. So basically, I've got this line L, and if there's some point P not on that line, right? There's tons of lines that could go through P. There's infinitely many lines that could go through P, but only one that's going to go through P and be parallel to L. And if we think about that, that makes sense, because parallel means that like the distance between these lines has to be equal in all places. They have the same slope. There's only one possible line. Similarly, we have the perpendicular postulate that states basically if I have a line and some point not on the line, there is only one line through that point that's perpendicular to the original line. Again, we could have, there's infinitely many lines that could go through point P, but only one of those is going to go and cross this line out at 90 degrees. And later on, we'll actually use a compass to construct these different parallel and perpendicular lines as well. So again, using a diagram, I would recommend trying to identify parallel and perpendicular lines in these questions 1 through 3. So pause, try it, come back for the answers. So number 1, a pair of parallel lines. So if I'm looking at the diagram, parallel lines, I have these arrows. Let me change so I'm not using the same color as the diagram. These arrows here show me that's the notation that tells us that these lines are parallel to each other. Notice that these other 2 lines don't have those arrows, and we don't have enough information to know that those other 2 lines are parallel. The only 2 we know are here and here. And those lines would be called line DM. And DM is parallel to line EF. And this is the notation we would use to write that. The little symbol here means parallel. And remember, we name lines with 2 points on the line. And this intersection here is point M, right? M is right next to that. And even though there's not a dot there, that letter there is referring to that intersection, and we can name that M. So that's where we get DM and EF. Number 2, name a pair of perpendicular lines. Again, we have notation on our diagram. That notation for 90 degrees is the box. And so the only 2 I know for sure, well, technically, the only 2 I know for sure right now are these 2. We'll talk about a little bit more information later on that will give us some more, but right now, these are the only 2 we know. So I would call that lines DM and lines BM. So line DM, and our notation for perpendicular is the upside down T to BM. And then number 3 is FE. So let me see, where's FE? FE is here, parallel to AC. And your original thinking might just be there's no way it's parallel, because it asks us to explain how we know. So you might be thinking, well, there's no notation, there's no arrows, we don't know for sure. We could also use this parallel postulate, okay? Because that says through any point, there's only one line parallel to this other line. So we know that these two lines are parallel. So since M is on both of these lines, DM and CA, this line DM is the only line that can possibly be parallel to EF that goes through point M. That's what the postulate says. Okay, M is a point not on this line, so there can only be one line that goes through it that is also parallel. So we could use that postulate also as proof, as evidence that CA cannot be parallel. So we just say by parallel postulate, there can't be a second line through M parallel to FE. Okay. Moving on. Pairs of angles. This is probably the most important part of this section, and this is an idea, or a couple of ideas here, that we're going to carry on through this unit. And these ideas are going to be very important. So do your best to study these ideas and make sure you understand these angle pairs very well. This first sentence here, this blank, we say a transversal. A transversal is a line that intersects two or more coplanar lines at different points. So this T, change back to our red here. This T is, so line T, that's this line here. This is a transversal. Okay, it intersects two or more lines at different points. So these are my two lines. T is the transversal. Okay, and it's the same setup everywhere. And in the future, we're going to look at transversals that cross parallel lines. But for now, we're just thinking about any two lines, transversal goes through them. And we have four different sets of angle pairs that we're going to be talking about. And so this first angle pair are called corresponding. It says two angles are corresponding when they have corresponding positions. For example, 2 and 6 are above the lines and to the right of the transversal. So I kind of think of this transversal makes 8 angles. Okay, let me zoom in here a little bit. So the transversal makes 4 angles here and another 4 angles here. So when we talk about corresponding, the 6 and the 2 are both in that same position. They're in the top right position. That's why they're corresponding. So like this angle and this angle would also be corresponding angles. Moving on, alternate interior. So it says two angles are alternate interior when they lie between the two lines and on the opposite sides of the transversal. So the alternate, let me do the interior part first. Interior means inside the two lines. Alternate means opposite sides of the transversal. That's where we get that from. So interior is inside the two lines. Alternate means opposite sides of the transversal. So again, like where I just put these 2 dots, those would also be alternate interior angles. Similarly, we have alternate exterior angles. So as you might imagine, exterior refers to outside of our 2 lines. So the 1 and the 8 are outside, and the alternate refers to opposite sides of the transversal. So alternate exterior are opposite sides of the transversal outside of our pair. And then finally, consecutive interior. So again, interior, inside the 2 lines, consecutive, right next to each other. Okay, some people call this same side interior. Our book uses consecutive interior. So notice when we move down to this final question, we've turned our diagram. So these are our two lines, and now this is our transversal. So we've just kind of rotated a little bit, but the idea is the same. So what I would do is take a second and give this a try. Look back at our diagrams above and try to match these up and identify all of these different angle pairs. Okay, so corresponding. So remember, I like to think of it that transversal cuts this into two sets of angles, and so corresponding are the ones that are in the same position. So top left, top left. So angles 1 and 5, angle 1 and angle 5. The top right would be angle 2 and angle 6. Bottom left, right? These are both in the bottom left position. So that would be angle 3 and angle 7. And then the final pair would be angle 4 and angle 8. Alternate interior. So interior, inside the two lines. Alternate, opposite sides of the transversal. So this would be angle 4 and 5. Angle 4 and angle 5 are alternate interior. And angle 2 and angle 7 are also alternate interior. Alternate exterior. So exterior is outside of the two lines. Alternate is opposite sides of the transversal. So angle 3 and 6 are alternate exterior, as well as angles 1 and angles 8. Consecutive interior, which again, some people think of as same side interior. So inside the two lines, same side of the transversal. So 4 and 7. And then the other pair would be angle 2 and angle 5. Again, I cannot stress how important knowing these angle pairs is. So please do your best to learn these and learn these well.